Hello, everyone. The project we are going to pronounce today is TAM search database, influx database. My name is Luobin.
My name is Neree Davo.
And I'm Brenton Polk.
So before we introduce the influx database, I will have a short introduction for the TAM search database. So what is TAM search database? TAM search database, as the name stands, is a database developed essentially for TAM search data or chronological data. It is a measurement of data chases through the TAM, and it is built to hold general analytics data such as survey metric, network data, and events, and so on. So for example, as you can see from this diagram using a temp search database for recording temperatures through 12 p.m. to 7 p.m. Changes are measured over time with temp search database, and this is not enough. And what makes it distinct are wide range data left circle management and the summary and analysis of many records function. Temp search database were mostly for financial, trading data, and solve transactions, but today can be used to measure any type of data or events. It could also monitoring weekly gas prices, yearly temperature change, hourly passenger count on the subway, and any stock market you care. So here is another example, as you can see from this diagram. It keeps monitoring the Google stock price from 2016 to 2019. Okay, let's take a look for the history of the temp search database. So first one, RD2 is the earliest temp search database. It comes with join function. And next is Graph-it. Graph-it is RD-based database which written by Python. It has an improved driving function compared to RD2, but it has issue with horizontal scaling. An open TS temp search database use HBase solved horizontal scaling issue. And next is called Keras database. Keras database is an improved addition of open temp search database. And next one is influx database, which is the one we are going to introduce today. So let's go to the next slide. So influx database is an open source temp search database developed by Influx Data. This type of database focuses on high performance reading, writing, efficient storage, and the real-time analysis of massive temp search data. It is widely used in DevOps, IoT monitoring, real-time analysis, and so on. So as you can see from this table, Influx database currently ranks first in the temp search database at the DB engines ranking, which is very good. All right, so Influx database is simply to deploy and easy to use. It fully utilizes the features of the Go language in the term of technical implementation. Influx database can be deployed independently without any external dependencies. It can provide a query language similar to SQL, which is very convenient to use. And meanwhile, Influx database has abundant aggregation computing and sampling capabilities. It provides a flexible data retention policy. Users can freely set the data retention time and the number of copies, while ensuring the data reliability. Storage space has also been managed to a certain extent. So on the other hand, the Influx database also provides flexible continuous query to sample massive amounts of data. And in terms of compatibility, Influx database supports multiple types of protocols such as HTTP, UDP, and other native protocols. All right, so basically, Influx database has the following features. Users can set the saving time of the metrics, and it supports time-related function like the minimum, maximum, something we used in SQL, and it supports continuous query, just like I said. And it supports HTTP. It has built-in HTTP API, and it has similar syntax compared to the SQL. The user can set the number of copies of data in the cluster, and it supports regular sampling data. Also, Influx database comes with a web management interface, which is user-friendly. Right, I'll hand it to Neree.
Okay, I'm taking from here. So I will talk a little bit about Influx data formatting and schema design. If we look at the picture, it will be harder to understand what each part means. So to get a better comprehension of Influx database and know how to design the schema, some basic concepts need to be known, which are a measurement. The measurement is a metric object which is equivalent to a table in a relation database. And what you need to know is each measurement can have one or more metric value, which is namely field described later. Now we have the row here is called is what we call data point, and tags generally can only identify data source. Most time series tags are the same, and the key and value of each tag must be string. We also have a field record, which records the actual metric value. The metric value is the value of that field, and each metric is called field. So field is just each metric. A timestamp is the time to generate data and can be accurate down to nanosecond. Next. So compared to other time series application, Influx data modelization is distinct and unique. The main notion that we need to remember here is the time column, which is present in any of the Influx database. And as seen in the picture, Influx database store the time spent associated with particular data. InfluxDB allows the use of multiple fields, and on the disk, data are most of the time organized substantially in blocks of time, which help for basically that help mainly for the measurement. The tag set, which is just a collection of tag key value. And what I like here is this make the operation very on field very faster. So we in InfluxDB data model, each measurement have a timestamp which is associated with set of tag and set of field. The field set represents the actual measurement reading value, while the tag set represents the metadata to describe the measurement. Tag set value are indexed and field set value are not. But also, while you declaring tag set and field data, you can set to string, integer 64, float 64, or boolean, and don't matter if it's a field or a tag set, you can set up the variable to that. But fields are limited and cannot be changed without rewriting the whole data. InfluxDB is created with Influx client, and while designing the schema, it's recommended to make sure to encode metadata in tag, since there will be more performance query on tag that's on the field. They're also required to, it's not required, but it will be good to avoid using keyword such as tag or field to bypass the use of double quote. Avoid high cardinality, apply better memory usage for varied database workload. Cardinality basically refers to the number of the value in the set. Also, they recommend when you read the document to avoid unexpected reaction. If you want to avoid unexpected reaction when query data, you don't need to use the same name for tag and field, for example. make a difference between data with tag than measurement name, because with InfluxDB, same measurements are merging together while current data. And to finish with a general requirement, reduce the need for a regular expression by not inserting no more than one piece of information in tag. So we need to look also carefully to shard group while designing Influx schema. Shard group is just where InfluxDB store data which is organized by retention policy, and the data store is with timestamp. So timestamp is something very important. This time is called shard duration, and its management or optimization required to find a steepness between performances provided by longer shard and the flexibility provided by shorter shard. And according to InfluxDB documentation, before setting shard group duration, you need to make sure to not have no more than 1,000 point series and 100,000 points per shard group.
Okay, so now we're going to look at some code snippets, and we're going to start with a Java code base that is part of the InfluxDB Java client. This first point snippet is basically creating a POJO for a point that is to be committed into the database by the engine, excuse me. A POJO, first of all, stands for plain old Java object, and it's basically just a class that is intended to carry data throughout a program or a system. The first thing that we have defined in this point class is a string called measurement. It's just going to be the name of the measurement that you would want to perhaps query by, and is something that you would want to have the point persisted as by name. Excuse me. The map of tags is a map of a string and another string, and that's basically just a set of indexes that we want to persist this data by for a quicker lookup. The number is actually the timestamp, and you can see that we also have a time unit precision that specifies that it's going to be done in nanoseconds. The map for the fields is, again, a map collection of fields that is the actual data that we want to persist along with the timestamp. And then the rest are basically internal faculties that we won't have access to. You can see they're all private and static final methods and variables. These are things that the client is intended to use, but not the user. So for our next snippet, add fields from POJO. This is from the same Java client code base, but what this portion is a builder method that basically takes a POJO that the user can create and then looks for a column annotation that the POJO's fields have been annotated with in order to figure out what to persist in the into the database. So everything taken by this builder method is going to be a field, and it does so through the reflection API. The reflection API is basically a bunch of facilities within the Java programming language that allows it to inspect code at runtime in its byte form, and then take information from that code after it's already been compiled and already been running. The downside to doing this through a reflection API is that it can be costly at processing time. So beware of that. Now for our next snippet, we have the write points function, which is actually from the InfluxDB server code base. This particular function is a relatively short one, but what it does is write points to the database engine. You can see that for the length of the buffer writer, it checks to, or for the length of the array of points, it checks to see if there's enough memory available in the buffer to write it, and then it checks to see if the buffer is actually empty. In addition to that, if it's empty, it will try to avoid a copy from any place in the buffer. In this case, it would be the beginning, but it will try to insert the array of points directly into the buffered writer and put out an error otherwise if it can't do it. But if the buffer is not empty, then it goes through a copy operation and finds the point at which the last data that was put in there was ended, and then it will try to insert the new information from that point in the index onwards, and then it'll try to flush the context. The context is just it's a Go programming language facility that basically ensures that a chain of Go routines that have already been started can all be stopped if something errors out or crashes. This way you basically get call stacks cleared and memory released. And then after that, if everything goes well, it's just going to return nil. You can think of it as kind of like a null, and then it finishes. And our last bit of code is actually going to be a Flux query. Now, Flux is a general purpose language that was built by InfluxData, seemingly as a replacement for InfluxQL. But it differs in that you can create separate standalone programs out of this. And what this particular query does is basically say, if we're looking at a particular bucket, we're going to get a bucket called example bucket, and then we're going to use the pipe forward operator there in blue to then filter by a time range. In this case, our time range is 15 minutes prior from where we are at the point of the starting of the script. And then it's going to further pipe forward that into another filter that basically just gets the measurement, the measurement field, which is CPU, the field called usage system, and then another one called CPU total. And then after all of that is done, it's going to pipe forward to yield, which is actually called at the end of any script, but it may be necessary if you have multiple queries in one script. Here it's explicit, but it's not actually necessary for this small example. And then here are the references that we've used. We have several documentation pages, as well as the links to the GitHub source code files. And this has been our presentation. And so if you have any questions, we'd be eager to take them. Thank you.